Hello, in this demonstration, Transparent I/O will show you how we solve the virtual machine noisy neighbor problem by restricting the amount of I/O that is given to each virtual machine, which enables greater VM density per physical server. Our host-based solution is all about controlling, managing, and prioritizing IOPS. Our solution works with the storage hardware you have today and what you may buy in the future. There is no impacts to applications, there is no need to reinstall or reboot the server. Based on the way that we manage storage, we can enable you to be scale up or scale out or both, allowing you to move to a software-defined storage architecture at your pace. One of the problems we solve today is I/O contention. In 5 years, IDC says that 37% of all physical servers sold will be virtualized. They also say the mean number of VMs per server will be 13, while ESG claims that in 2 years, 30% of those being surveyed will have over 25 VMs per server. This will make the noisy neighbor problem even bigger as all those virtual machines fight over I/O. How do we solve this today? Well, many people do it by over-provisioning, which we believe leads to a lot of inefficiencies. We solve it by getting more than double the IOPS from your existing infrastructure. We have a solution that puts you in control of the IOPS. You decide what workloads or virtual machines they go to. You can even do this dynamically. And ultimately, this leads to increased virtual machine and workload densities, which lowers CapEx and operating expense costs related to servers. While this demonstration will focus on the noisy neighbor problem, our solution is also applicable to other workload contention on physical servers, such as running multiple SQL workloads. In the demo you're about to see, the VMs are all running on a Windows 2012 server with Hyper-V using 3 SAS drives. In the lower left-hand corner is a list of the virtual machines for this server. There are 4 that are currently running, 2 that are paused, and 1 that is off. In perfmon, we are showing the amount of I/O per second that each VM is taking from the underlying SAS drives. Specifically, there are 3 VMs showing up in perfmon. The yellow line is a VM running an online transaction processing workload, and the red line is a VM running a decision support system workload, or simulating email, SharePoint, etc. And the green line is a VDI workload that is running. And the 4th VM down here labeled greedy is one that will simulate a noisy neighbor that takes I/O from the other VMs. There are also 2 additional VDI VMs that will be started later. In the lower right-hand corner, we are dumping out the 6 LUNs that we've created using Transparent I/O's host-based solution. These LUNs were created using disks from the system, and to the OS they appear just like any other LUN would. The difference is how we manage these LUNs, enabling us to get more I/O out of them than a traditional LUN, which also allows us to control the I/O and allocate it as needed. You can think of this as being very similar to QoS, except in this case we can dynamically change or set the IOPS going to a specific LUN. Now we're going to start a script in the virtual machine called greedy, which is going to steal I/O from the other VMs. You'll now see a black line spiking and the other workloads decreasing in I/O performance. As VM densities increase and the number of physical servers become virtualized, this problem will become greater and greater. However, we have a way with Transparent I/O to solve this problem dynamically, because we can have the ability to set the desired IOPS per LUN. So what you're going to see here is we're going to go off and we're going to set the specific IOPS requested for LUN ID 110, which happens to be the greedy VM. You'll see that appearing down in the right-hand corner in just a second. So now we go set it to 90 IOPS, and you'll see that the noisy neighbor is now dropped to 90 IOPS. Next, we're going to go set LUN IDs 101 and 102, which are the online transaction processing and the decision support system workloads, to 300 IOPS each. And then lastly, we're going to go set each of the VDI workloads, although only one is currently running, to 120 IOPS each. So what you're seeing is that each VM is being given a band of I/O values, and transparent I/O maintains conformance to each band. This allows us to launch more VMs without violating the need of each running VM. Now we're going to go start the second VDI workload, which we've given about 120 IOPS, so we'll resume that VM. We'll see the line come in there. And we'll see that it starts to level out near 120 IOPS. And now we're going to go and we're going to launch the third and last VDI workload, also set to 120 IOPS. You'll see it start up in there, and you'll see that we're able to contain it in that particular band. So now at the beginning of this, we saw the impact of the noisy neighbor that came to each of those workloads and sort of pushed the I/O all over the map. But now using transparent I/O solution, we're actually able to restrict the amount of I/O going to the noisy neighbor, as well as restrict it going to the other workloads so that more workloads can get done. So to recap, our solution enables you to increase VM densities out of existing servers while solving the noisy neighbor problem. You no longer need to allocate excess I/O to solve the noisy neighbor problem. Transparent I/O enables you to be in control of IOPS and to decide how many IOPS to give to each workload based on the needs of that workload. We enable you to get more IOPS out of your existing storage infrastructure, as well as take advantage of the IOPS you may be getting with storage purchases tomorrow. Thanks for watching.